While generally linked with thunderstorms, these phenomena are noted to be lasting far longer than a typical lightning bolt's instantaneous flash, and being entirely separate from E.S.D. Elmo's fire. Some records from the 19th century detail these strange balls ending in an explosion that leave a scent of sulfur. Various accounts through the ages mention ball lightning drawing scientific attention. In 2014, an optical spectrum that appeared to be of a ball lightning incident was shared, featuring a high frame rate video. Lab tests have created effects bearing visual resemblance to ball lightning accounts, but the association between these experiments and the actual occurrence remains elusive over the centuries. Scientists have put forward numerous hypotheses to elucidate ball lightning reports. However, scientific data on this subject remains sparse. The belief in its existence heavily depends on public reports, which have yielded inconsistent results. The rarity and unpredictability of observation opportunities make the data scarce, leaving the existence of this unique natural phenomenon as yet unproven. Ball lightning has been speculated as a possible source for myths involving glowing balls, such as the Anchim Hayin from the Mapuche culture in Argentina and Chile. According to statistical studies in the 1960s, about 5% of the global population claimed to have witnessed ball lightning. Another study analyzed reports from approximately 10,000 cases. The Gervais of Canterbury Chronicle by an English monk contains perhaps the earliest known reference to ball lightning, dated 7 June 1195. A fascinating incident from the Great Thunderstorm that took place at a church in Widecombe, in the Moor, Devon in England, on 21 October 1638 resulted in death and injury. Witnesses describe an 8-foot ball of fire attack and enter the church, nearly demolishing it. The alleged fireball split into 2 parts, one part crashing through a window to exit as the other disappeared within the church. Attributing the fire and sulfur odor to the devil or hellfire, locals found a metaphysical explanation for the event, some even blaming the event on 2 people playing cards in the pews during the sermon, hence inviting divine retribution. As we navigated the Gulf of Florida on the 29th of August, a colossal fireball descended from the sky, shattering our mast into countless fragments. The impact also divided our main beam and 6 other planks, both above and below the waterline. This spectacle claimed the life of 1 crewman, severely injured another, and left our vessel on the brink of a blaze. The only thing that saved us from flame was the torrential rains. A similar incident occurred in 1749, where Admiral Chambers, aboard the Montague, reported a sighting of a giant ball of flaming mass. This occurrence, too, resulted in severe structural damage to the ship and grave injuries to crew members. The explosion from the impact was equivalent to that of 100 cannons firing at once, leaving behind a smoky, sulfurous odor. Professor George Richmond of St. Petersburg tragically failed in his attempt to replicate Benjamin Franklin's kite. Flying experiment in 1753, a ball of lightning interacted with his apparatus, striking him fatally on the forehead. His engraver was ultimately knocked unconscious, and his residence marginally damaged. During a storm in 1809, the British ship Shim's Warren Hastings was fiercely attacked by 3 fireballs. One fell onto the deck, claiming a sailor's life while igniting the mainmast. Efforts to retrieve the body turned fatal when another ball struck the crewman, inflicting severe burns. The last blow came from the 3rd fireball, killing another sailor and leaving a nauseating sulfuric odor. Ebenezer Cobham Brewer, in his 1864 edition of A Guide to the Scientific Knowledge of Things Familiar, referred to this manifestation as globular lightning, describing it as slow-moving balls of fire or explosive gas that sometimes descend onto or run along the earth during a thunderstorm. The phenomena can occasionally divide into several smaller fireballs, each capable of detonating with the ferocity of a cannon. Further corroborating such incidents, Wilfrid de Fonville, in his book Thunder and Lightnings, translated to English in 1875, reported a staggering 150 accounts of globular lightning encounters. The fascinating phenomenon of ball lightning, albeit slow and occasionally still, nonetheless harbors destructive potential. An incident in the Stralsund Church demonstrates this as an exploded ball lightning spewed smaller orbs that exploded like shells. Tsar Nicholas I, a Russia Aya of Russia, also chronicled an encounter with a fiery ball of lightning in the presence of his grandfather, Emperor Alexander I. His dramatic recounting describes a gripping storm during a religious service, where a powerful gust blew out the candles and a fiery ball shot through the window, whirling around the floor before whirling out of the door. Despite the terrifying spectacle, the Tsar emulated the calm demeanor of his grandfather, who remained resolute, a faint smile playing on his lips afterward, helping to abate his initial fear of storms. British occultist Aleister Crowley shared another account of a ball lightning experience, or what he referred to as globular electricity on Lake Pasquini, New Hampshire in 1916. He found himself in a calm amazement at the stationary, dazzling globe of electric fire that hovered mere inches away from his knee on bursting. The globe provided a discernible contrast to the ongoing pandemonium created by the storm outside. Jennison, of the Electronics Laboratory at the University of Kent, presented his first-hand observation of ball lightning in a 1969 Nature article. Whilst aboard an all-metal airliner, he observed a 20 km diameter luminous sphere emerge from the pilot's cabin and travel down the aisle. Maintaining a steady course and height, these anecdotes highlight the versatility and intricate behavior of atmospheric electrical phenomena such as ball lightning. Let's discuss the recurring and wide-ranging encounters with the enigmatic phenomenon known as ball lightning. It commenced on April 30, 1877, with a sphere of this peculiar lightning making its presence known in Amritsar, India's Golden Temple, witnessed by several bystanders and immortalized on the front wall of the Darshani Diori. The story then unfolds onto November 22, 1894, in Golden, Colorado, where an extended display of such a phenomenon occurred. It was an awe-striking spectacle that took place amid the wind-filled atmosphere around the School of Mines' new Hall of Engineering, causing wonderment among onlookers. Another remarkable appearance took place on May 22, 1901, in Uralsk, a Kazakh city of the former Russian Empire, bringing a shattering spectacle to a refugee home during a thunderstorm. The phenomenon took a devastating turn in July 1907, leaving the Cape Naturalist lighthouse keeper in Western Australia unconscious, with the event hauntingly chronicled by his daughter, Ethel. Intriguingly, one incident documented in Bischofswerda, Germany on April 29, 1925, describes the ball lightning's interaction with human-made structures like telephone wires and its bewildering behavior. Adding to the noteworthy accounts is the fictional yet seemingly semi-autobiographical reference in Laura Ingalls Wilder's 19th century children's book that describes the ball lightning traversing in their kitchen during a winter blizzard, making the phenomenon universal in nature. Further intriguing are the accounts from World War II pilots who observed similar peculiar orbs of light exhibiting odd maneuvers, subsequently coined Foo Fighters. This narrative spans continents and centuries, while consistently dwelling on human encounters with the electrifying and mystifying phenomenon of ball lightning. On a series of distinct incidents across the globe, an intriguing atmospheric phenomenon known as ball lightning has been observed by stunned witnesses. The first notable instance was on August 6, 1994, in Uppsala, Sweden, when a mysterious ball lightning reportedly made its way through a closed window, leaving a round hole of about 5 km in diameter. A thunderstorm had occurred around that time, so it was hypothesized that the event was connected to the storm. Residents had reported a lightning strike, which was subsequently validated by a lightning strike tracking system at Uppsala University. 11 years later, in 2005, Guernsey saw an aircraft supposedly hit by lightning, spawning multiple fireballs spotted by onlookers on the ground. On July 10, 2011, in the midst of a powerful thunderstorm in Czech Republic's Liberec, a huge ball of light with a tail 2 meters long penetrated a window into the local emergency services control room. This ball lightning caused chaos bouncing around before disappearing. It left behind a hint of burnt cables, disrupted all communications, crashed computers, and destroyed a monitor. In 2014, an alarming incident took place on a Loganair Flight 6780 in Scotland, where lightning struck the aircraft, resulting in ball lightning appearance in the forward cabin. The aircraft plummeted several thousand feet, frighteningly close to the North Sea, before an emergency landing was executed at Aberdeen Airport. In one of the more recent events, June 24, 2022, amidst a hefty thunderstorm in Lower Austria's Liebenberg, an elderly woman witnessed a bright yellow burning object with licking flames, streaking across the sky after a dazzling cloud. To ground lightning display, this peculiar event was registered as ball lightning by the European Severe Storms Laboratory. These ball lightning incidents present varying characteristics. Some move unpredictably, hover, repel, or get attracted to objects, and even traverse solid substances, causing destruction or leaving no trace at all. They show dissimilarities in appearances as well, transparent or translucent, uniformly illuminated or multicolored, radiating flames or sparks, and can take shapes ranging from spheres and ovals to rods and discs. Despite its resemblance, ball lightning is distinctly different from St. Elmo's fire. There's an array of stories about how they disperse, sometimes gradually fading, getting absorbed into objects, popping, or even painfully exploding. Meanwhile, opinions are also divided about the harm they cause to humans. However, it's imperative to always treat eyewitness accounts with a pinch of skepticism while studying the typical properties of ball lightning. Ball lightnings, comparable in luminosity to the common household lamp, are often visible during daytime, with red, orange, and yellow colors being the most prevalent. These naturally occurring phenomena typically last from a few seconds to over a minute, maintaining fairly steady brightness throughout their lifespan generally. They move at slow speeds, usually in a horizontal direction, but their movement can also be vertical, stationary, or irregular. Interestingly, these balls of light have shown an affinity for metallic objects, allowing them to move along conductors like wires or metal fences, and have been noted to appear undamaged within metal aircrafts. The disappearance of these ball lightnings is usually swift and can either be silent or marked by a loud explosion. In terms of sensory experience, observers have reported smelling odors reminiscent of ozone, burnt sulfur, or nitrogen oxides, and experiencing unusual sensation of heat, particularly when the ball of light vanishes. These occurrences are quite rare. Scientific investigation into the nature of ball lightning has been ongoing. In 2014, scientists from China's Northwest Normal University recorded and published their study of what they believed to be natural ball lightning on the Tibetan Plateau. They captured detailed digital video footage of the ball lightning's formation, duration, and the resulting spectrum. Throughout their experiment, they detected emission lines of multiple elements, including neutral atomic, silicon, calcium, iron, nitrogen, and oxygen. Their observations revealed that ball lightning exhibits a sensitivity to electric fields and that their temperature is lower in comparison to the parent lightning. Ball lightning studies also have a historical dimension. Inventor Nikola Tesla could reportedly create small artificial ball lightning and performed various demonstrations of his skill. These were a side curiosity for Tesla, who was more interested in the potential of higher voltages, power, and remote transmission thereof. Multiple symposia on the subject have been carried out by the International Committee on Ball Lightning, ICBL, and other related groups that emphasize on unconventional plasmas. Unfortunately, the last expected ICBL symposium in 2012 had to be canceled due to a scarce number of entries. In the laboratory, attempts to generate ball lightning have resulted in visually analogous results, but a concrete link remains elusive to the scientific community. In an endeavor to understand the elusive phenomenon of ball lightning, research institutions such as the Max Planck Institute have reportedly replicated a similar event using a high-voltage capacitor underwater. Many contemporary experiments have adopted the use of microwave ovens to create mini plasma balls in which a match or another small object is ignited or extinguished. The burnt part of the object flares into a big ball of flame as plasma balls hover near the top of the microwave oven. The Israeli team, consisting of Eli Jerby and Vladimir Dykjar, detailed that these microwave plasma balls consist of nanoparticles with an average radius of just 25 nm. Another experiment from 2007 stimulated silicon wafers with electricity, converting the wafers to vapor and causing oxidation. This resulted in small, glowing spheres rolling on a surface. Scientists Antonio Pavaio and Gerson Paiva of the Federal University of Pernambuco in Brazil have consistently created these long-lasting balls, reinforcing the hypothesis that ball lightning might be oxidized silicon vapor. Despite being introduced into the realm of science in the mid-19th century, ball lightning remains a mystery with no universally accepted explanation. The prominent hypothesis suggests that ball lightning is vaporized silicon on fire due to oxidation. This hypothesis gained considerable traction in 2014 with the first ever recorded spectra of natural ball lightning. Matthew Francis coined the term dirt clod hypothesis, which suggests that ball lightning shares chemical attributes with soil. The phenomenon of ball lightning has garnered various intriguing proposals over the years. Piotr Kapitsa believed ball lightning to be a glow discharge ignited by microwave radiation, drawn from lightning clouds to the ball by ionized air. The ball, he suggested, acts as a resonant microwave cavity, adjusting itself to the wavelengths of the microwaves to maintain resonance. Another theory, the Handel master soliton, postulates that ball lightning is powered by a huge atmospheric master and appears as a plasma caviton at the antinodal plane of the maser's microwave radiation. In 2017, a team from Zhejiang University in Hangzhou, China, advanced the idea that the luminosity of ball lightning results from trapped microwaves within a plasma bubble. The formation of this bubble is attributed to a relativistic electron bunch created at the tip of a lightning stroke, which ionizes the local air and evacuates the resultant plasma to form the bubble that traps the radiation. As microwave continue to generate the plasma, a visible flash is created and maintained, gradually decaying until the ball fades, discharges the microwaves, and, in some cases, explosively destabilizes the interaction of microwaves with glass, which allows their passage. Could also explain why ball lightning can occur indoors. Meanwhile, Julio Rubinstein, David Finkelstein, and James R. Powell put forth their hypothesis that ball lightning is a detached St. Elmo's fire originating when a conductive object, such as a ship's mast, amplifies the ambient electric field to the point of breakdown. They proposed that free balls of ionized air have the same potential for amplification. If such ionized balls maintain their ionization, they become solitons in the flow of atmospheric electricity. Powell's kinetic theory calculations derived that the size of these balls is set by the second Townsend coefficient related to the mean free path of conduction electrons at the point near breakdown. In related phenomena, certain industrial microwave ovens were found to trigger wandering glow discharges that continue to glow seconds after power shut. High-power, low-voltage microwave generators also produce arcs which exhibit afterglow. Powell's measurements of these spectra suggested that the afterglow predominantly arises from metastable no ions, which have a long life at low temperature. The onset of this glow was observed in air and nitrous oxide atmospheres where such ions exist, but not in argon, carbon dioxide, or helium atmospheres where they do not. The ball lightning phenomena might be explained through Oleg Meshcheryakov's theory. He proposes that ball lightning is made from a collection of nano or submicrometer particles, each one functioning like a battery. According to this theory, a surface discharge shorts these microbatteries, creating a current, ultimately forming the ball of lightning explained as an aerosol model. It accounts for all observable properties and processes of this lightning form. The now public Project Condin report suggests buoyant charged plasma formations, similar to ball lightning, are created by unique physical, electrical, and magnetic elements. They could be transported rapidly due to the balance and influence of electrical charges in the atmosphere still. The understanding of the scientific motivation behind these, under different weather and electrical conditions, is not fully explored or understood. However, this theory doesn't fully explain the occurrence of ball lightning, as per Stenhoff, and may not stand up to close scrutiny from the scientific community. In 2008, a study by Kouré and Kouré pointed out the similarity of the hallucinations experienced by people suffering epileptic seizures in the occipital lobe and the observed features of ball lightning. The study suggested that the rapidly changing magnetic field surrounding a close lightning strike could stimulate neurons in the brain. Consequently, this led to the theory that lightning could trigger seizures in a person near a strike, connecting the phenomenon of epileptic hallucination mimicking ball lightning with thunderstorms. Though this theory doesn't justify the physical damage caused by ball lightning or cases where multiple people observe the phenomenon, the University of Innsbruck has put forth a theory suggesting that the magnetic fields produced by specific types of lightning could lead to visual hallucinations similar to ball lightning. Such fields could cause neurons in the visual cortex to fire, producing a magnetically induced hallucination called magnetophosphonies. However, this phenomenon is ambiguous and lacks comprehensive understanding. In December of 1899, Nikola Tesla proposed a theory that ball lightning was actually composed of superheated but ultra-thin gas. This prompted a host of other theories, such as Girondin's 1976 hypothesis, stating that ball lightning could be an electric field vector spinning at microwave frequencies. Stanley Singer, in 1971, countered this theory, highlighting that the rapid electrical recombination time wouldn't support the reported lifespan of ball lightning in 2006. M.I. Zelikin put forth a theory grounded in a mathematical foundation, attributing ball lightning to plasma superconductivity. In 2016, HCUDU added to this by theorizing that ball lightning occurs when a relativistic electron bunch, formed at the tip of a lightning strike, generates powerful microwave radiation under appropriate circumstances. You posited that the microwave's pressure could possibly clear out the subsequent plasma, forming a bubble that continuously captures the radiation. Lastly, A. Messon in 2010 presented a comprehensive theory at the 10th International Symposium on Ball Lightning in Kaliningrad, Russia. He explained all observed properties of ball lightning as collective oscillations of free electrons. In this model, ball lightning fades quietly when the density of charged particles is insufficient and explodes when the density is excessive. He also suggested the possibility of stationary waves of electronic oscillations within a plasma ball contributing to concentric luminous bubbles.